Solving three variable systems. Okay, so we just got finished solving two variable systems, and with two variable systems we graphed lines, and those lines either intersected in one point, no points, or they were the same line, so they had infinite number of solutions. In this case, we're not dealing with lines. Instead, we're going to be dealing with planes. You can kind of think of these as sheets of paper that go on forever in every direction. So here, if we have three planes that intersect, they can intersect in three different ways. The first one is with exactly one solution. So as you see, these three planes intersect and they cross in exactly one point. So right there where that black dot is where they cross. That would be one point, one solution. Another way they can cross is where they cross and they make a line at their intersection. That would be infinitely many solutions. And the last way is we could have no solutions. So these possibilities are no solution. None of those have all three planes crossing one point or one line at the same time. So just like two variable systems, we'll have exactly one solution, or we'll have infinitely many solutions, or no solutions. This isn't something you'll need to write down about the graphs. I just wanted to give you a visual representation. Okay, we're going to start with our first example. So I have a box out to the side where you can write down all of your steps as we go. The first step is to pick a variable to eliminate from two equations, or find an equation with a missing variable. So in this case, we have an equation with a missing variable. We'll do another problem later where we don't have a missing variable. So this is actually kind of an easier case to deal with whenever we have one variable already missing. So since we're missing a y from this bottom equation, we're going to take these two equations up here and we're going to eliminate y. That will leave us with a system of equations in two variable, and that's a lot easier to solve. So we're going to eliminate y from the top two equations here. So if I pull those top two equations out, if I'm going to eliminate y, I will probably want to make the y's 6y and negative 6y. So I'm going to multiply this entire top equation by let's do that by a negative 2, and the entire bottom by a positive 3. That will give me a 6y and a negative 6y. So now I'll rewrite my two equations. I have 10x plus 6y, minus 2z equals 8. And for the next equation, I will get negative 6x minus 6y plus 6z equals 12. Okay, so my y's are now ready to be eliminated because they add to 0, so I'll cross out my 6y and my negative 6y. Adding down, I get 4x plus 4z equals 20. Okay, so now I'm going to take that equation that I just found, this 4x plus 4z equals 20, and I'm going to take that original equation that was missing the y, and I'm going to solve that. Notice that I have an x and a z in each of these. If I had eliminated, say, x instead of y, this top equation would have a y and a z in it, and I wouldn't be able to do anything because the bottom one has an x and a z. So make sure that if you have an equation that's already missing a variable, say y, you eliminate the y from the other two equations so that they match now. Okay, so if I'm going to solve this system, I'm going to do it by elimination. You could do it by substitution if you would like. I'm going to multiply this bottom equation by 4, and my x's will cancel out. So my top equation is 4x plus 4z equals 20. My bottom equation now becomes negative 4x plus 4z equals 20. So when adding down, I get 8z equals 40, so z equals 5. Okay, now that I have z, I can easily find x by using one of these two equations on this page. I'm going to use the bottom equation, so I have negative x plus 5, instead of a z I'm putting 5, equals 5. Subtract the 5 over, and switch the signs, I get x equals 0. So I have z is 5 and I have x is 0. All I need to find now is my y. So I'm going to take my x and my z and I'm going to plug it back into one of the original equations at the very top of your problem, and I'm going to find the y. Well, it's not any use to plug it into that third equation because there's no y there, so I'm going to plug it into the top equation instead. So I'm plugging 0 in for x. Okay, so now I can solve. Negative 5 times 0 is 0, so that just goes away. So I get negative 3y. I'm going to subtract the 5 over, and I'll get a negative 9 on that right side. Now dividing both sides by negative 3, I get y equals 3. Last step is to write it as a point. So it's always going to be x, comma y, comma z. So my answer is 0, comma 3, comma 5. Now note that in Math Excel it might not always have you put it as points. Sometimes it might say what does x equal, what does y equal, what does z equal. So just be sure that you read the blueprint on Math Excel and see how it wants you to enter your answer. On your unit test, however, you will definitely need to put it as a point. Okay, let's do another one. This time you'll notice that we don't have a missing variable. All three equations have x, y, and z in them. So what's going to happen is I'm going to go ahead and number each of these just so I can call on equations 1, 2, and 3. We're going to take two pairs of equations and we're going to eliminate the same variable. In this case, I am going to eliminate the z's. They just look easiest to me. I could have eliminated the x or the y. It really doesn't matter, but the z's are what I'm going to go with. So I'm going to start by taking equations 1 and 2. So let me just copy those down. Okay, I'm going to eliminate z from this. So all I need to do is multiply my top equation by 3 in order to get opposites. So if I multiply that by 3, I get 15x minus 3y plus 3z equals negative 3. So I've multiplied the top equation by 3, and now I can eliminate. Okay, so now I have one equation that is in just x and y. Now I need to get another one. I just took equations 1 and 2 to eliminate z. Now I'm going to take, I don't know, maybe I'll take equations 1 and 3. I could have also eliminated my z from 2 and 3, but 1 and 3 look easier. So I'm going to take equations 1 and 3. And I'm going to eliminate z again. Be very careful to eliminate the same letter both times. If you didn't, you would end up with something with a z in it down here for your equation, and then these two would not be able to be solved. Okay, so if I eliminate z, I'm going to need to multiply my top equation by a negative 2 in order to get opposites. So I actually don't want this line here yet. Okay, so now I can go ahead and add down. Okay, so notice now I have these two equations, and they're in only one variable, and I can now solve for my x and my y. Okay, so it looks like I'm going to want to multiply this second equation by a negative in order to make that a positive y. So my first equation stays the same, 17x minus y equals 3. And then I'm going to multiply my second equation by a negative 1 in order to get a positive y right there. Okay, when adding down, I get 26x equals 0. If I divide both sides by 26, I'll get 0 again, so x equals 0. Now plugging that 0 back into one of my equations, I'm going to go ahead and plug it into this 9x equation. So if I plug x in, or 0 in for x here, I get 9 times 0 plus y equals negative 3. Well, 9 times 0 is just 0, so I get y equals negative 3. Sorry that I'm trying to squish all this on one slide. Okay, so I have two of my three variables. All I have left to do is find the other one. So I need to solve for z. I can plug my 0 and my negative 3 into either equations 1, 2, or 3. It doesn't matter. I'm going to pick equation 1 to plug them back into. So in equation 1, I have 5 times 0, because x is 0, minus a negative 3, which is going to be plus 3, plus z equals negative 1. 5 times 0 is just 0, so that goes away. So I get 3 plus z equals negative 1. Subtract the 3 over, I get z equals negative 4. So now I have my final answer of 0, comma, negative 3, comma, negative 4.